Good morning, good afternoon, everyone. Our topic for the IoT mini project is health monitoring system, and these are the contents of our presentation. Well, our project addresses the growing trend of integrating Internet of Things technology into healthcare systems to enhance patient care and health management, with a keen focus on body temperature and heart rate monitoring. Well, our powerful sensors, pulse oximeter, and a digital thermometer to provide accurate and continuous data streams. At the core of our system lies the ESP32 microcontroller, orchestrating the integration of sensors, processing real-time data, and facilitating automated response mechanisms such as medicine dispensing through a servo motor. By showcasing the seamless integration of sensor data processing, actuation, and user interface design, a project demonstrates a practical applications of IoT technology in healthcare, contributing to personalized and accessible healthcare solutions and revolutionizing patient care.
So moving towards problem statement and objectives. So here, real-time monitoring, which develops a system capable of continuously monitoring body temperature and heart rate in real time using sensors such as MAX 30100 pulse oximeter. Second is data processing and analysis. Implement algorithms to process and analyze the data collected from the sensors, including calculating heart rate. Third is automated response mechanisms, which integrates actuators such as servo motor control pillbox to automate responses based on the predefined health thresholds. Fourth, user interface design. It enables user interaction to set thresholds, view historical data, and receive alerts. Fifth, system integration and testing that conducts through testing to verify the system's accuracy, reliability, and effectiveness in real world scenarios. Next. So here the individual contribution. Next. So moving towards the summary of literature survey, here are many methods used. For example, wearable device with IoT integration, IoT health monitoring systems for cell phones, IoT-based healthcare monitoring, and some real-time health monitoring system. Next page. So also there are many examples of methods. For example, intelligent monitoring systems for hospitals, IoT-based healthcare monitoring system, and something like a rigid flex wearable health monitoring sensor patch for IoT connected healthcare applications. Next.
So the block diagram of the proposed system is we are using temperature sensor for sensing the temperature of the human body, LCD for displaying the output, pulse oximeter for sensing pulse oximeter sensor for sensing the pulse rate of the human body, pill box so that we can give patient pills at the proposed time or the time requirement, and we are also having a power supply as every function requires. Next slide. Hardware systems, as our friend Hershey said, we are using SP32 microcontroller, temperature sensor, pulse oximeter, servo motor to connect it to pillbox so that it rotates on the given time. And also we are using Arduino IDE. Next slide. Implementation and experimental setup. This is all our experimental setup. We can see the LCD connected, the temperature sensor, and also the pillbox with servo motor on it. Mm.
So the result what we found was our health monitoring system using IoT technology works effectively. Real-time monitoring, people can track their health instantly like checking body temperature and heart rate. Automation medication, the system gives medicine automatically when it's needed, which help manage chronic conditions. Real world testing, we tested the system in real life situations and it performed very well. Feedback of the people found the system easy to use and helpful for managing their health. Moving on to conclusion slide. The conclusion in simple terms is that a new system uses technology to help people manage their health better. It lets them keep track of their body temperature and heart rate in real time. The system also gives medicine automatically when needed, which helps people manage long term health problems better. Testing the system in real time in real life shows it works very well. To make it even better, Experts need to keep improving it and working together. This new system is a big step forward in making healthcare more personalized, proactive, and easy to access. These are the references. Thank you.
So here I am explaining the code. The starting section includes the necessary libraries for the projects, like interfacing with I2C device, pulse oximeter sensor, temperature sensor, LCD and servo motor, etc. Next, we are defining the LCD address and dimensions, then creating the LCD object with a liquid crystal. Then next section declares global variables and objects used in the program. POX is an object of the pulse oximeter class used to interface with MAX 30100 sensor. TS last report and servo last move are variables to keep track of time for reporting and servo movements respectively. Objects for one wire temperature sensor and the last temperature library are created. An LCD object, LCD, and a servo object, servo motor are declared. Then void on beat detected. This function is called whenever a beat is detected by pulse oximeter. It simply prints beat detected to the serial monitor. Then we have we have attached servo to pin 18. This is setup function, which is called once when Arduino board is powered up or reset. It initializes serial communication, set pin 33 as an output for servo motor, initializes LCD and initializes the pulse oximeter. It also sets up the DS18B20 temperature sensor and attaches the servo motor to pin 33. So here it is, and we also move servo every 10 seconds, like servo motor have to rotate in every 10 seconds. Then next loop function, which runs continuously after setup function, it updates the pulse oximeter readings, request temperature from DS18B20 sensor, and prints the heart rates, SpO2 and body temperature to the serial monitor and LCD display. Additionally, it moves the servo motor by 90 degrees every 10 seconds and updates the position based on time elapsed. Thank you.
This is our IoT model health monitoring system. We have used DS18B20 temperature sensor. We have used 16x2 LED. We have used ESP32 development board, and we have used this MAX 30100 oximeter to calculate heart rate and oxygen level. And we have used SD90 servo motor to drop the pills according to the time period. It drops the pills from here and the pills appear according to the time. We have set the time to 30 seconds for now, afternoon, morning and dinner time.